Hey everyone, Eldritch Spetri. Oh, Eldritch, I made it so the first redeem goes away once someone gets it now, but it's still happening. But yeah, hey everyone. I'm on a call with Femvox and Poison Mouse here. And at least for the first hour or so of stream, we wanted to go through some questions from a Portuguese math exam. So, Mouse, could you explain like what these exams are?
This is the high school final exam, so we have to solve this one. Well, this is a practice exam, right? So when we finish high school and we want to go to university, we all have to do this exam. It's a nationwide exam. So it has a lot of topics from calculus, derivatives, complex numbers, trigonometry, the basic um, theorems like the MVT and Lagrange theorems, things like that. Probability, combinatorics, and that's all we have to do. Oh, and on this one we don't have it, but there's also a question that you have to use the calculator to solve it.
Oh,
It's
okay.
similar to the last one. You have to like they give you like a trigonometric function. You have to find like where it started. So it's like sometimes it's like a physics question, but math oriented always.
Okay, nice. And Slim, thank you so much for the raid. I hope the rest of your stream was good. Uh,
That's why.
yeah. Mouse was just going through and explaining that this is a Portuguese like 12th grade exam here, and they test on a variety of topics. It looks like so. We just kind of wanted to go through and solve some of these questions for fun. Um,
Just to mention, like they give you like a seat sheet at the top.
oh, I saw
So
that. Yeah.
for example, in this, you need to study the continuity, right? You have to you can't use hospital, you can't use it. Or hospital,
Oh,
Hmm.
you
yeah.
can't use it. So you have to in general you always find like the basic limits, like the one on the bottom right. You have the limit to 1 plus 1 over
Oh.
n to the n equals e, things like that. You need to in general you get a limit like that after manipulation of the
Mm.
exercise.
Okay. Some
Like the
hypnosis to people math cool. Oh, yeah.
for
Go on.
example, there's the progressions like arithmetic progression and geometric
Oh yeah.
progression. Sorry, you won't get the formula for the limit to infinity because you have to deduce the formula from that one. They won't give it. Just an example, the way they the things they allow you to do in the exam.
Mm.
Interesting. Okay.
So what happens if you use L'Hopital's rule? You just lose points?
Yes, zero.
Oh,
Oh.
zero.
Points.
Okay.
Yeah.
Okay.
It
Wow.
says
Yeah.
when they give you the exam, they also give you the criteria. Like let's say I'm just guessing. When in the first exercise, you use you want something from university, like from a friend or something like that, and you use it. They have you options. They have options in the criteria. You can do this and that. So you have what they give you like 3 ways to solve that exercise. If you do something different from those 3 ways, you get zero.
Mm.
You're not allowed to think outside the box, right? That much. Like for example, just a quick example. Like it's easy to calculate the diagonal of a square, right?
Mhm.
So you do it from like it's the side length square root of 2, right? So
Yeah.
you know that, but you need to prove it if you're going to use that you know, that assumption. You need to prove it on the exam. So
Oh.
it's where to use the Pythagoras theorem. So, and things like that. Because you
Interesting.
have to prove.
I don't know if I like that.
Well, in university it happens the same. Like on my degree, the professor doesn't care what you use to solve the problem. He just wants the right answer. You know, you
Yeah.
don't you can copy all answers from the person next to you if it's the same exam, and he doesn't care if you know the subject or not. You know, it's a it's an approach. You know.
So we're gonna learn some
Oh.
Portuguese.
Yes.
Looks like it. Okay, I've been scrolling through the first one. I see number 4 involves a square and some complex numbers. That one's kind of grabbing my attention right now.
Yeah.
I'll get a
They
screenshot
they
of it.
want they want you well for translation. I don't know in English if there's the word affix. I don't know if you know what affixo is. You know, in the second sentence.
Maybe just like affix is a word, as in like just keep it a
Yes.
constant,
No,
or like
affix
place it there, I
means
guess.
no. It's like when you have okay. For example, this complex number ZB, it means it's in the position, or the point is square root of 3 and minus 1, correct?
Okay.
Or in this case minus 1 square root of 3. So that's the affix. It's the image of the complex number.
Oh, so yeah, rather than like it being written as an imaginary number, it would be just 1,3.
Yes,
That's a point.
or in
Okay.
this case minus 1 comma
Oh
3.
yeah.
Square root of 3.
Okay.
No, square root of 3.
Yeah. Right.
Okay. Minus 1 square
There we go.
root of 3. Yeah, that's the image. So
Okay.
what they want is the point C is the affix or the image of one of the roots of order 6 of the complex Y. Knowing Y is also a solution of this equation. Find the other solutions of this equation.
So wait, is W a root of unity of order 6?
No, that means that W is one of the roots of order 6. So you have square root of 6. So you have 6 roots, right? Then C is one of them. W is
Oh, the 6th root of Z?
yes. 6 is is one of the roots. Yeah.
Or you're saying the number 6?
Knowing
No.
what does it say? Knowing that W is one of the
Yeah.
solutions of this equation.
Yes. Yes, that's what
And
it
then
means.
point C is one of the roots of order 6 of the complex number W.
Yes.
Huh.
That's what it says.
Okay.
So W to the 6 will solve the equation.
Okay. No, is that right?
I might have that reversed.
C to the 6th. Like if we took that point C to the 6th power, that would be a solution of that equation, maybe.
So root. Okay, so W is a solution, and so C is the 6th root of W. Okay. So we know that W cubed plus 8IW squared plus W plus 8I is 0. This looks factorable.
This factors nicely, doesn't it?
Yeah.
Yeah, you can see this factors nicely.
I'll just switch back to Z's. Z plus 8I. Z plus 8I equals 0. So Z squared plus 1 z plus 8i. And then I guess z plus and minus I. Hey, Puika. Minus AI? Yeah.
So one of those. So I and minus 8i. One of those is our W, right?
Yeah.
Oh, you know, or what's the actual question? I'll determine the rest of the solutions. Okay. Well, didn't we just get them?
Well, we have to work out which.
Okay. Here's the thing. We first should find the point C. We have
Yeah.
B. We need to find C first. Then from C we can get the other roots of the complex.
So all we really know is that B is on a circle here. We know this length. Oh, you know what though? We can take it. Yeah, we can find that point, can't we? Because we take the negative slope reciprocal of the slope and we can find. Yeah, okay.
Oh, they're perpendicular?
Yeah, if it's a square, those two diagonals should be at right angles in the middle.
Pui is correct. Minus 8i is one of the solutions.
Oh no.
Oh, again. Sorry.
I'm confused why we need the square at all here.
Well, we probably want to find point C, I think.
The easier way to find point C is calculating the argument of the complex number. So
Yeah. Oh yeah, minus 1 root 3. Those are nice numbers.
Oh, and someone's making an interesting point.
yeah,
With understanding how complex multiplication works with how the angles add.
swim is in a good direction.
Yeah, like C, like it's a pi over 4 rotation to the left.
Yes.
Times, oops, whatever B is. And then you have to scale it.
Yeah, you need
For root
to,
2, for reasons I'm not
yeah.
clear
Well.
on. I guess it's an isosceles right triangle, that's why. Color code. You know, I'm just gonna say thank you, even though it's not my birthday.
Isn't that pi over 2 though?
No, pi over 4. It's a square.
It's half a right
Square.
angle for the rotation. So pi over 4 looks good. And I believe it is a square slim, yeah. Wait, I was saying it is? Okay.
It says on the question. It says the square OABC.
Oh, I'm sorry. I'm thinking of going from the center, but you're saying going from point B, sort of from
Well,
OB to OC. I see it. I see it.
it's the
Like,
easier
as
part.
like a
Like if
vector.
you go, like if you do
Yes,
OB,
yes.
OB is the diagonal of the square.
Yeah.
So the example I said earlier, right? Then you get you have the complex length, the modulo of the ZC. You get it and multiply with the diagonal. Like you can get, okay, it's 4. So you can calculate for that. But the easier part would be the square root of 3 over -1, right? Or even better, you can do square root of 3 to the second power plus -1 to the second power, and square root of both, like calculating the magnitude, right? And you get square root of 4 equals 2. Then you
Oh,
multiply
yeah.
by
I forgot that.
Yeah, there's the 2 there. Yeah, I was gonna say.
then you can multiply with the diagonal.
Fraction math. 16 plus 3 is 19? That's a stupid angle. Isn't that too big? I made a mistake, didn't I?
4/3 pi. Oh, your 4/3 should have been 2/3. Oh, 2/3.
Oh, 2/3. Yeah, yeah.
Oh, 11
It should
pi
be,
over
it
12.
should
That
be
sounds better.
11 pi over 12.
Okay, that's
Yeah.
better. Yeah.
That looks good.
Yeah, that's correct. No, and not square root of 2, but that's not okay. That's correct. Correct. It's all correct. Never mind me.
Yeah, that
and so
makes sense.
W that to the power of 6?
Now, yeah. Now now you do double equals that complex number to the power of 6.
Okay.
Yeah, the 8i, right? That's what we're getting.
Yeah.
The
Minus
negative
8.
8i. Yeah.
Yeah. Minus.
That angle can be simplified.
Yeah.
You need to the square root of 6.
Ooh. The square root of 6?
But if you want to do it, okay, you already have 11 pi, right? Yeah, it can be simplified. It can be pi over 2.
Oh, that is going to pi over 2?
Yeah. It's
Shouldn't it be 3 pi over
minus
2?
Yeah, or minus
pi
pi.
over 2 because it's minus 8 I minus 8 I.
Minus 8 pi.
Yeah,
Well, minus 8 pi
Yeah.
is too much because we get a common denominator, right?
I think you're right, Don. It'll be 3 pi over 2 because you can subtract 8 pi over 2 because that's 2 revolutions. Sorry,
8 pi over
4
2.
revolutions.
Collar cone, congrats.
2 revolutions. Yeah, this looks good.
Oh, and then
because that's
That's
a
just-
minus 1.
um
Minus I, sorry, minus I.
yeah, so minus 8i is a root like we found originally just by factoring it.
or 6 revolutions, right? You can
It might have been 6,
12,
yeah.
12 pi over 6, right? Yeah, that's right.
Hey, Bruno.
So, okay, so we know what W is. Oh, well then, so the other 2 roots are these 2?
Yeah, and
Yeah,
then you can use, if you want to use Ruffini or something like that, and calculate the other roots.
What's Ruffini? I've heard the name.
You know the name? It's when you divide a polynomial by its roots. Ruffini rule.
Oh,
for
okay,
example.
yeah. That's just the process of it's Ruffini's rule, and that's just where you divide out the root to get a simpler polynomial.
Yeah.
Okay.
You can use that. You can divide by that complex number we got.
But if you just know grouping, this gets a lot easier.
Sure.
Okay.
Well, you already have the roots, right? -1, minus I, and -8, it's already done, right?
Yeah, but I guess if we didn't know that, that's kind of a neat way of
Yeah,
getting the other roots.
I think it simplifies things, I guess.
Okay. So let's look for another question. If any of these jump out, feel free to call them out.
That was a cool question.
Yeah.
If you want, this one is about asymptotes.
Number 6?
Yeah.
Yeah, sure.
It says consider a function continuous in R and the function g of the domain 1 was infinity, and let me see so I can read it from here. That you know f is an even function. The line of equation y equal -3x plus 1 is an asymptote of the graph x f, sorry, 1x tends to -infinity, and you know that g of x equals f of x over ln x squared plus x. Show that the function g has an horizontal asymptote. Which graph?
Hmm.
Okay, so f has the asymptote as x goes to -infinity, and we want to prove g has a horizontal asymptote. I'm sorry, what did you say the last part was?
That it has an horizontal asymptote in its Twitch graph, you have the function g and you have an horizontal asymptote there. That's what
Okay.
it says.
What does this star over here mean? Does it mean it's a harder problem?
Well, the star means that it's you have to do it. That question
Oh.
you can avoid. Well, they have a certain number of questions and others you can replace. You have to do one or the other, things like that.
Okay.
They have that now. They didn't used to have that, but now it's common.
And so if f is an even function, this asymptote should also be true for positive infinity?
Well, usually, yes. It usually means that you have one for each side. But usually
You
when
flip
you
the
have on the
sign, I guess.
positive side, you need to flip the sign.
Yeah.
We need to flip the sign?
Flip the sign of that slope. So
Oh,
it'd
the
be
slope.
3x plus 1, I
Yeah,
think.
Okay, nice, yeah.
yeah, that's it.
Because I assume the thing we want to do is, because g is only defined for 1 to positive infinity, like look at the limit of g as x goes to infinity and hope we get a constant.
Oh, good idea. Good idea.
Sure, you can do that. But here's the approach we usually do. I don't know in America, but in Portugal we have I don't know how do you generally calculate the -3x, for example, in the oblique. We call it oblique or slant asymptote, right?
Yeah, slant asymptotes. Yeah.
How do you calculate the -3 and the 1 in general?
I always
You
forget
take the
that.
derivative, I guess.
No, you can't use derivatives
I
here.
think you do division, and it's like,
No, like for example, in Portugal, like for example, how do I explain this? Okay, if you want to find the m or -3, right? We say limit 1x to infinity or plus infinity, depend, of f at x of f of x over x.
Hmm.
That equals -3,
Okay, makes
Right.
sense.
right? But if you want to find the one, it's like this: limit of x tends to x to the plus infinity or minus infinity of other functions minus the slope times x. You know, that's the one of the approaches. Yeah, like that. That's one of the no -3. That's for -3.
Oh
The
yeah,
first one.
sorry, that's what I meant to write. Can you
So
repeat what the
in-
other one was? You subtract an x?
Yes. Uh, let me try to explain. Let me do something really quick. Just a second. Just a moment, so I can. Okay. Okay. Just a second. So we have predefined situations. Okay. If you want, that's for the them. The other one is the function minus the slope times x equals 1 in this example, right?
So,
So
f of
and
x
you
plus 3x.
and we have yeah, like that in parentheses. Not yeah, but yeah, minus, yes, correct.
Okay.
So and in parentheses if you want
Oh,
all
yeah,
of it.
okay.
Yeah, okay. And we know that the definition of us asymptote, it's the distance from the asymptote to that point, right, is 0, right? That's the
Goes to
definition.
0, yeah.
Oh, yeah.
Yeah, goes to 0, right? So that's how we, in general, approach these questions, you know, at
Okay.
the high school level at least, right?
Okay. Um, and so if we want to get a horizontal asymptote, we'd want to take g of x over x and find it 0. And then we could find what the kind of y-intercept is with the other format. So maybe as x goes to positive infinity, g of x over x, and we can think about this limit instead. So f of x over x ln x squared plus x. And so we know f of x should be approaching positive 3, right?
X squared.
Oh yeah, thank you.
But you need to, you're multiplying by x, right? Oh, okay, or maybe, okay, you define z of x. Okay, okay. I was, okay, please continue.
Okay.
I have another approach after.
Okay. Hmm. I I feel like there's going to be a particular way that we should conclude this, but from here I would kind of say that if the top is approaching a constant, the bottom is unbounded. So I would expect to get 0 for this overall limit.
Yeah, but this doesn't go to 3. This goes to negative infinity.
Yeah,
Sorry.
yeah,
Yeah,
your
negative infinity.
fact is correct. But you can do it says f is an even function.
Oh,
So you can do the trick, like you can swap the limit. Instead of going to minus infinity, it goes to plus and you change the sign, right? You can do that.
I see what you're saying, Finlux. So where like f of x is unbounded. I think maybe a better way to phrase it, like, can we split it up into a product of limits? Because this we know is +3, and the other piece is just 0.
Yeah, that's a good idea.
And so we should probably, I mean, I guess we should show that the other limit is not unbounded, or that it's something finite, and then presumably we've answered the question. So it should be the limit as x goes to infinity, g of x minus the slope times x, but we're saying the slope is 0, so it's just g of x. I mean, I can write minus 0x just for completion. Hey, Papadoria. Yeah. So f of x over ln x squared plus x. Poison Mouse, who I'm in Discord with right now, is Portuguese, and they have some pretty cool like tests for 12th grade students, so we decided to take a look and solve some problems from it together. How do we deal with this limit? I mean, I guess I want to go back to what I was saying before with f of x being, well, no, you're right, Felix, they're both unbounded. I guess f of x is growing linearly as x goes to infinity, and the bottom is linear plus a little bit. But that's not very, like, I feel like that wouldn't get points on a test.
2 log x plus x. And the top looks like 3x. Kind of looks like 3x over 2 log x plus x.
Right.
And so the bottom's like, if the log x was another x, that would be the same, but log x is slower, isn't it? So this is like less than 2x. That's an idea. So what does that mean?
Well,
The top's
that's
bigger.
true. That's true. That's true. The bottom part grows slower in comparison. Yeah. But the X makes it a bit larger.
Like, there's maybe some kind of like plus minus 2 ln x trick with that. I'm not sure if it would actually help though.
Do we have to do some kind of comparison?
Ooh, maybe.
What are we hoping to do? We're hoping to show this as some constant.
Yeah, it's a constant. Yes, it's a line. It's a horizontal line.
R1B, welcome in. That's the name of the tablet that I use. I just got it because it was cheap. I didn't do much research. but it works fine.
It's the same as mine.
Oh, cool. Welcome in. So yeah, squeeze theorem is definitely a thought. How would we phrase this? I want to say something like f of x. I assume is less than this. That might be dangerous, but I don't know what to put for the lower part either. We don't even know that it. Yeah, if we can bound this limit above by something, that would be nice. We don't necessarily need to actually squeeze it. Hey, one side gamer.
I think this is a positive 3 now, right?
Ooh, you're right. And it, like, honestly, we don't have enough information, I don't think, to know the comparison.
Yeah, I guess we don't really know if it's which side it's on. If it's a fence, we don't know if it's above the fence or below the fence.
Yeah.
G is only positive, right? You don't have the negative side, correct?
Right.
I think you people are complicated a little bit too much.
Oh, really?
Yeah, for sure. Well, you started in the good way, Don. Then I think you complicate a bit more. Like it's correct to the second line. Then instead of adding that x at the denominator, you could do f of x over x, then ln of x squared plus x over x. And you start by substituting the values, and you calculate. Since they're all continuous functions, you can split the limits, right? And you start calculating, and it's all done. The exercise. Like instead of you can have f of x over x, right, on the second line, divided by ln of x squared plus x over x, and it's basically done.
So you're
You
saying,
just need to.
I think I guess we ended up doing that in reverse, but
Yeah.
You're saying
Like we
like
first.
divide it by the thing to make it look like G.
Yeah. So yeah, and you need to divide. No, you're okay. Yeah, that's it. Over x, because you can then cancel the x's, and you have
Oh.
g of x after, over x. You need over x.
So
No, over x on the second. Okay, you keep it the way it was, that way. No. Okay.
There's a stream delay. I'll just stop for a
Okay,
second.
I'm sorry. No, the other way. No, the other way. Because you're inverting the terms.
So like, would you rather just see it as like a big fraction then? ln.
Yeah, sure. But
Okay.
you sure. Okay.
Maybe like that.
Yeah. Plus then over x. Okay.
Okay.
Then you can cancel the x's, but keep it for now, right? Now we know from the question that f is an even function, correct? So we know that f of x over x, when limit tends to minus infinity, is -3. And we also know that the limit of f of x over x when the limit tends to plus infinity is 3 because it's even, right? So
Mhm.
if f of minus x must be equal to f of x, correct? Now you can replace it 3 over the rest. Then it's just calculating the limits.
Something like, or like
Yeah, like
I
that.
don't know if the one should
Like
go on
that.
the bottom or not, but
Yeah, it's fine. It's fine. Correct.
okay,
You
okay.
keep you can do that because they are continuous functions. As long as they are continuous functions, you can split the limits.
Okay.
I like that. And
And then
you can even split like
individually.
ln of x. Yeah, do it both so we can use the rules of the exam. As you don't have you can't use the L'Hopital, so let's use the rules we have. No,
No?
the other way. No, sorry. Yeah, you split between
Yeah, don't
ln
split
of
the
x
limits.
squared.
Split the
Oh, I see.
Split
Yeah,
okay,
with the
what do you
addition.
say? Yeah, split of this what is called in linear algebra. When you have an ODE, it's I forgot the name in English. So sorry.
It's
Okay,
okay.
that's it.
What-
I forgot the number. You can have like it's linear. Right? When it's
yeah.
linear, you can split the elements. Yeah, that's it. So now you can calculate the limits, right?
Okay.
So
Hmm.
you have the fundamental limit, which is limit of x tends to infinity of ln of x over x. That goes to to 0,
Right.
Yeah,
right?
this
That's
looks
0.
like 0.
So you have to manipulate that if you want, or we all know it's 0, but if you want, you can manipulate. It's pulling the 2 out of the ln,
Mhm.
right? It's going to be the same result, but just for fun, it's good to know, right?
Yeah. Um, I I can write it.
It was funny. Don is finally studying for his Portuguese high school exam.
Thank you, Bob. Hey Shreya, in One Side Gamer. Sorry, it's basically we're given f as an even function. It has that horizontal asymptote as x goes to infinity, and we need to prove that g of x has a horizontal asymptote. Is the short version.
It's the light version, right?
Yeah.
Oh, that was clever. That was clever. I didn't think of that. Yeah, so we had to divide the top x.
Yeah, that's how we do it in high school because we can choose Hospital. Well, you can use the derivative definition if you prove it, right? There are exercises you have to prove the definition. So, and then you can use it.
So we're supposed to just get 3 at the end of this? What is this saying?
Yes. That's then we have the horizontal asymptote, which is
So g goes to 3.
y equals 3. That's our horizontal.
Oh,
When
okay.
you tend to that function
Because
from
this was g, wasn't it? Right here?
yeah, that
Okay.
was
I see what we're doing.
that's what
Yeah,
the limit was. Yeah,
this makes more sense.
yeah.
Very sneaky.
Yeah, that's we have to do a lot of manipulation. We have exercises on our books that, like for example, if you use L'Hopital, it gives you a quick result, right? But here
Yeah.
you have to manipulate a lot. Like sometimes you have to add 1, 2, 3. It's like complete the square most of the times, right?
Yeah.
And it's I believe it's incredible in high school for that. You won't ever use it again in university.
Yeah, like
Yes, you
the
will.
hot
Yes,
pedals are
you
so
will.
much easier.
You'll start streaming on Twitch, and then somebody will come
Yeah,
in and give you a
yeah,
question. You got to
and
do it. You got to know it.
yeah. And I meet on, and he makes me study harder. I know. But it's in my opinion, it's amazing the way they make you do stuff. Like it makes you think. Like
Yes.
in my college professor or university professor, and I told them once, oh, I could solve this limit in 5 seconds without Hopital because with Hopital we have to define the derivative on top, derivative on bottom, and things like that. And there, and I add a two and I divide it, for example, it's quick. And he said, no, we don't use that anymore. You need to use L'Hopital or Taylor series. You know,
Mm,
it's
Hmm.
sometimes it complicates a bit more. That's my opinion.
yeah. It's good to know different ways to do these things.
Yeah. Shrey is asking to explain the question again briefly. So just to kind of go back through it, f is a continuous function on R, g is a continuous function on 1 to infinity. We're given f is even, it has a horizontal asymptote of minus 3x.
Oblique,
Oh,
oblique or
oblique.
slant.
Yeah, sorry, I might, yeah. A slant asymptote of minus 3x plus 1 as x goes to negative infinity. And then they give us g of x that's defined in this way. And they're asking us to show that g has a horizontal asymptote. And so the main trick was to take the limit as x goes to infinity of g, but you kind of have to divide the top by x and the bottom by x. And then you can use some things you know about f of x to kind of solve that limit from there. It's not the way that I would have solved the problem. That's the way that the students who take this exam are intended to do it, which is kind of interesting.
Well, you can use a comparison. We learned that, like we don't we're sometimes there's no definitive value, right? We do a lot of comparisons, like in solving series and things like that. But there we have to follow their rules, so they give you numbers that they know that will work for their example. You know, they it's a different thinking process, I guess.
Yeah.
I like this question a lot. This is a really good question.
Yeah.
There are a lot more of those on those exams. Like sometimes they focus on those questions. It's the harder questions.
Maybe we can take a.
So,
Oh yeah.
Mouse, I want to ask you again another
Sure.
question. The word par, does this mean even?
Par, yes. Like in the golf
Ah,
par,
yeah, that's
that
good. That's
means
good. That's
even.
good.
I
Thank
was
you.
thinking
If you
like
want,
parity, but yeah.
yeah,
Yeah.
yeah. If you want odd, it's impar. You just add the prefix I am impar.
Impar,
So
yeah.
that's like
Okay.
not
Yeah, yeah.
even then. I assume m just
No,
like negative.
no, sure. Sometimes yes. Maybe not in that
Oh,
many
okay.
direct way because we have some other ways to say no to things. You know, like uh, uh, like impulse. Like it's the pulse impulse. You know,
Hmm.
sometimes that will look like that. Number 8 is also complex. Number 9 is complex. Uh, number 10 is geometry. That's a plane, and you need to find some
Um.
a point. Okay, the number 11 you need to use the calculator.
Oh, okay.
Why
Honestly,
do they
like
have
all these look
names next to the
tempting.
questions? Is that the person who
Oh,
wrote the
they
question?
Yeah,
yeah.
that's the person that wrote that question.
Okay, yeah.
It doesn't happen in the real exam. This is a mock exam, let's say.
Yeah.
Oh,
Yeah.
okay.
So they are part of the group on Facebook. So that and they are the best at doing that. They write books in Portugal and things like that. And like to have fun. They do it pro bono. This stuff.
Oh.
Oh, that's cool.
Yeah. And they do Zoom um, classes for sometimes for around this time because next week it's the Portuguese exam.
Ooh.
So some teachers, they help other people, and
Yeah.
to that. So, see that one, the derivative, right?
Yeah, 15 looks kind of cool. I like these analysis type ones.
Yeah, yeah. He is a fantastic professor. And he offered me his book with an autograph.
Oh, cool.
I went to meet him in my town, and he didn't hesitate. Without meeting, it was the first time he saw me. He gave me a book. Then for fun, the year after that, I went to the same place for another presentation, and I took the book for him to sign. It was fun.
I love that.
He's a cool person. And
Nice.
he helps everyone on Facebook. If you ask him a question, he always does his best to answer it.
That's awesome.
So translating the question. Okay, consider the function f of domain R such that f is differentiable in R. The line of equation y equals -1 is an horizontal asymptote for f when x tends to plus infinity. And then that's the derivative formula. It's bigger than 0. So that
Positive.
means
Oh,
the
increasing.
derivative is positive. The derivative is
Yeah.
positive, right? So that the function g defined in R, which is g of x equals f of x e to the power of fx, is decreasing in R.
Ooh. Hey, Lucas. We have two people calling Lambert W function, which I have heard of it, but I don't know what it is.
Sorry?
Oh, people are asking if this is related to the Lambert W
Oh,
function.
no. That's too advanced.
Oh, yeah,
That's too advanced. So Lambert, it's too advanced.
yeah.
This one's
I've only
got a
heard of
little
it.
star on it.
Well, true, but they don't teach it in high school, right? We can approach the same way, right? F of x over x is, or in this case, is 0. Then we have the b, which is or in this case, horizontal asymptote. So f of x equals -1,
Yeah, it's
right?
something like that, I guess. Because it's
I think we can.
increasing up to -1.
So I think we can have the same approach, right?
Okay, that makes. I was really surprised this function to be decreasing, but this makes more sense after like kind of doing that sketch of it. So I don't know,
So
like we
should
could go to the limit definition for G.
Can we just differentiate G with the product rule and chain rule and things like that, or is that not allowed?
Yes, that's
Oh.
possible. Yes.
I'd rather do that then. So G prime. Oh yeah,
Well,
we were given
that's
formulas at the top, right?
yeah. If you don't know it from by heart,
Yeah.
you can.
F of x, f prime x, e to the f of x. Yeah.
Oh, factor out 1 plus f, and that should be negative.
Oh, or factor the other part out. E to the
Yeah,
f of
sorry.
x.
Yeah, factor the other part out.
Oh, you've been on a delay holiday? Oh no. Can you say that horizontal asymptote for that f prime a is 0? It'll never truly be 0. It's going to approach 0 though. Okay, and so we know.
No, That's positive and that's positive, right?
Mm-hmm.
That's positive, yes. E E can never be negative, so
1 plus f of x is negative though, because the supremum of f of x is -1. I guess less than, no, it never actually hit 0 as far, well, it theoretically
yeah,
could.
it's going to
Yeah,
be
be more can
near.
say in the limit.
Yeah, no, yeah, the limit is
Or like for a large
no,
enough
no,
x.
no equal,
Okay.
because it's an asymptote, so it will never touch the asymptote.
Yeah, horizontal asymptotes are like, they're sometimes weird because you can have a function that's like, it like pops up at first and then it comes down. So I was trying to be careful of that. I forget what function that actually is, but I know those are possible. It's not important. I don't think it's that important. Like, you know, say for a large enough x, this is true. Well, yeah. Decreasing in R though. Oh, but I can't. Okay, never mind. If it's strictly increasing, you can't have the thing that I said. Never mind. One more exam and then you're done. Nice, Lucas. Okay, so I think that's enough to show that G prime is less than 0 then.
True.
X to the 1 over x might be like that, Papadoria, I think. But if the function did look like this, it will be decreasing on that piece, so we can't have that. Okay. It's a nice little problem.
One more success.
Yeah.
They have a lot more. They do it like once a year. For this time, and there are a lot other more difficult, but there need to be a photo of sharing. Oh, well, I don't know if you want it, but I was going to cut some exercises from each from my choice, but you know, you could have wanted a different one. That's why I kept it the way it is.
Oh yeah, I mean, honestly, all of these would be cool to work on. These are pretty fun questions. I am gonna do this for like about an hour, but maybe we can do like one more for the road. So then I can just be available for like general questions.
This one, 12, you have to find the concavity, inflection points, and tell the coordinates, and show that the f of x doesn't have asymptotes.
Oh, we can go for a harder one then. Hey, Phobos.
The 13 one, you need to prove that the number 1 is false, and the second is true,
Ooh.
and give a reason for.
Okay, I like the look of this one then. Okay. So f is differentiable. F of 0 is minus f of 1. Yeah, Papadoria, I agree. These questions, like the analysis ones, are cool. I mean, these are all cool, but these are like fun analysis ones, especially.
Yeah, I think those are the best. I believe. But I don't like that much geometry, but
I was kind of tempted by
another-
some of these, to be honest, but I know the analysis ones are cooler.
Yeah, for sure.
Oh, I prefer the geometry.
I mean, we can pull a geometry one too, because we haven't done one of those.
The first
Before
one
we
had the
leave.
square in it, but I don't know if we really needed it that much. But
No, but I don't know.
Which one? Sorry.
The
that
first one we
first one
did.
had a square in it with the complex numbers, and we had to find point C.
Well, wasn't that the easiest way to find it? Like, you know a point, you know a square. All the roots there are all separated by p/4. But you know, it's simple. It makes it simple, right? Like it's a regular polygon,
Yeah,
so it makes it simple. Like an hexagon, you have to divide by 6. You know,
yeah.
I think that helps, right?
I like the way you guys did it. I was going to do it a different way. I was going to find a point in the center of the square and find the vector from the origin to the center, and then do a left turn and go the same distance.
Oh,
You
I was
can
going to
do
do it
that,
that way.
yes. You
Yeah.
can do that, yes. But like after all, you would get like well, not the radius, but from well, it would work, but a lot more work, I guess. But
Yeah,
you
I think my way would be harder. Yeah.
and
So what do we have to do here? F and G, two
okay,
functions F and G.
yeah, you go for it.
F,
Bam,
F is
read it.
differentiable.
Okay,
F is
yeah,
differentiable.
yeah,
F0 is minus F1.
yes,
G of x equals this quadratic, where A and B are
yes,
reals, A not 0.
yes,
And then what does this say? There exists a line R of
yeah,
slope minus B.
yes.
Declive looks like slope.
We've had that
And
slope. It,
tangent to the graph of
just to
G.
just to say something, in like slope, you can have a positive and a negative slope, but in Portuguese, that word goes for both ways, even though it means it's going down. It's funny.
It looks like decline. Yeah, it looks like
Decline,
decline.
yes,
oh.
yes. You see, it's funny. Like the first time I heard the word slope, and I asked the teacher, "Isn't this wrong?" And he said, "That's the way we have, you know." Like it's okay. Continue, fam.
Okay, consider the following
No,
affirmations.
you forgot the tangent to the
Tangent
graph.
to the graph of G. Yeah.
Okay, okay, okay.
And then
Consider
consider the following
statements
statements
or claims.
or claims.
Yeah, the
Uh,
domain.
the domain of the function 1 over f
Yeah.
is
R.
all the reals. All the real. Okay.
Yeah.
So that's the first claim. The second one, ordinate.
Ordinata means the y coordinate.
Oh, the
Y-
ordinate, right? Like the
Yeah, yeah,
abscissa and the ordinate
yes,
or whatever.
yes,
Okay, the
yes.
y coordinate of the point of tangency of line R
To the graph.
on the graph of G is 0. Oh.
So now they want
And
show
do we
that
have to show that affirmation 1 is false and
false.
that affirmation 2 is true?
Yes,
Um,
and they want
in
you
your
to
answer,
justify. Want
present
you
a
to,
reason to
yeah,
justify the falsity
yeah,
of affirmation
yeah.
1 and another to justify the verification, the truth of affirmation 2.
You're higher.
Okay, so how do we do it? So it's really like just two different problems. We have a F problem and a G problem.
Yeah.
Sorry, what was the part with F here?
The domain of the function 1 over F
Oh,
has to be all real numbers.
So
okay.
just from the first claim, we can see that it's false, right? Like or yes, I mean the second one.
Oh,
F
it's
of 0.
differentiable at 0, isn't it?
Yeah, it's
Um,
not. It's not. So f of 0 equals minus f of 1. That's impossible, right? Because 1 over f isn't defined at 0, right? So we already know why it's false, correct?
So it's, let's see, so f, this first f had domain all real numbers, so it exists everywhere. So
Yeah.
okay, f of 0 is minus f of 1. So that's a number anyway. That's a number, and then when we
Oh, that
invert
forces
it,
us
we
to
get
cross over 0. I think. It's like an intermediate value theory thing. Because if f at 0 is some positive number, then f at 1 is some negative number, and you have to cross over 0, and that causes you issues for 1 over f.
Yeah. One is correct.
oh yes.
Yeah, it's called intermediate value term. That's it. That's the name. We don't call it that. We call it Bolzano-Cauchy theorem or
Bolzano.
or when it's the corollary, it's Bolzano something whatever. It's one of the names. Just in university, they don't call it Bolzano. They call it Lagrange. Lagrange Bolzano. Yeah, that's it.
0.
Well, that's okay. That's the corollary, but you can have
Oh, okay.
and you see doesn't have to be 0, but means the yeah. That's it.
Okay.
Yeah, Phobos, we're playing
We're playing.
we're playing Are You Smarter Than a 12th grade Portuguese? And the answer for me is no, I'm not smarter.
But you know, I don't know if you agree with me, but well, not if you agree. Let me ask you something. Do you think it's a well balanced exam at the American level or not for the high school?
This is, to me, this seems harder.
Yeah,
I think,
Americans don't
but
have to do things like this.
yeah.
They tend to give us like, if you do a calculus class and you do the test associated with that, I feel like they make you do annoying computations, usually like annoying product rules and quotient rules and stuff.
Oh, here they don't do that. If you know it, you already practiced before, because they won't ask you like do the product rule or something like that. They don't ask that ever.
That sounds nice.
Even tomorrow is the 9th grade exam. What you call the okay, a quadratic equation, not equation. What you call the minus b plus minus square root of b squared minus
Quadratic
4.
formula, maybe.
Yeah.
Okay, quadratic. You can't use it. You need to solve the quadratic equation without using it. And a
Oh,
lot
yeah.
of other things. They remove it from the problem. You have to know it. It's crazy. They are making it harder.
Wow.
It's cool. It's fantastic.
Do
But you go to
So now,
university. If you choose physics, for example, you won't ever do this again, ever.
Wow.
Even in math, in physics, of course, but in math you won't ever do this again.
so for part 2, we should take the derivative of g, probably.
Yes.
And we'd get 2ax plus b, and then we want to set it to minus b. Let's see. Yeah, that could work.
Anyway, so the translation of this already fell out of my head.
We're trying to show that there exists there's a line with a slope of -b that's tangent to the graph of the parabola
Okay.
of the g function. That's what we're trying to show. No, we're not trying to show that. We were given that. We were told there
Yes.
exists a line of slope -b that's tangent to the graph of the g function.
We already know the answers. We need the reasons to.
Yeah, we got to prove that
Yeah.
the point where that line crosses the y-axis,
Yeah.
it is zero. The y value is zero.
The
What is
tangent
this?
line goes through the origin.
Yeah.
Okay.
Yeah. The way Fam said, it's correct. We need to find the derivative of g and equal that to -b.
Okay.
Yeah, then we could find the x value. And then we could find the equation of the tangent line, probably.
Just b over a negative.
Yeah.
Yeah, that's correct.
Oh, yeah. And a was not zero, they told us. So that's
Oh,
good.
good.
Yeah. Well, if it was zero, we would be having some hard times. But now we can find yeah, that's it.
Yeah, plug in the -b over a to get the y
Yeah.
coordinate.
Yeah, that's it.
B squared
So-
over a minus b cubed over a. No. B
You're
squared over
missing
a.
the-
Oh, what the?
Yeah. Yeah, that's
Huh.
it.
No.
Zero.
Did I do this wrong?
Oh, that looks good.
Oh yeah. Okay.
Because
No,
we
that's
wanted.
wrong. Okay, you already did the A, right? You removed the A from the first one.
Yeah,
Because you
I
did-
canceled it.
Okay, you already canceled. Okay. Okay, that's it.
Okay, I thought we had to go to like the equation for a line, but that saves us some work. Okay, nice.
That's it.
If you want to do one more, get a geometry one in there.
Is addicted.
Yeah, it kind of is.
It is, right?
Yeah, they're fun. They're fun.
Did any of the geometry
one-
ones jump out, Fembox?
Yeah, which one do you want?
Oh, I don't know.
There was a 3D looking triangle thing.
You can this one you can use dot product and things like that.
Oh, okay. Maybe we can go more purely geometry.
What's this blue trapezoid?
Oh, that's you have to use trigonometry here, and you need to find the area of trapezium or trapezoid.
That could be cool. Honestly, the stats I'm interested in too, but that'll be another time. And then did the other one?
What about this catenary at the end? That looks like
Catenary.
that might be harder. The last question, it was like that wire
Yeah,
hanging between the two telegraph poles.
Yeah, that's that's really a catenary. You can see f of x e to the power. That's a cosh. Of x.
Yeah, it looks like- it
not
looked
f-
like a
not of x,
yeah.
but I didn't pay it much attention, but it's a catenary.
You make the call, Fembox.
Let's do the one with the blue trapezoid.
Okay.
We usually get now questions like this or similar in the other levels. Like, for example, we have a bridge that, the Golden Gate in the US, right?
Yeah.
We have a bridge exactly like that.
Oh, really?
Yeah, it's maybe our is longer. I'm not sure, but it's the same material and things like that.
What is it called?
So
Or I'm interested to look up
so-
an image.
So we have a newer bridge that they have lamps, like posts and lamps on top of it. So one of the questions was calculate the angle that the posts must have. So and why they did that calculation. It's not to damage the water, the fish, right? Because the light reflects on the water and it affects the marine life, right? So we have some of the type of questions, like the size of the wings of an Airbus, because we don't like Boeing, right? So we have to use Airbus because it's the European counterpart. But uh, I don't make the question, so that's but you know because it's the new. It was a few years ago. The A380, the largest plane.
Nice.
We're mimicking the Brazilians. The Brazilians. They have a lot of tests like that. Not complicated like this, but they have a lot of questions like like a whole page of text explaining a question, like physics questions. If you go watch some of their questions next time, I can get some and you'll see it. Uh, it's and they have a lot of day-to-day questions like that, like utility stuff, right? Not just math oriented. You know what? You need to. It's related to day-to-day life, so it's cool.
That sounds interesting. Yeah.
Next time I'll get a Brazilian one, and maybe an advanced one. You thought this is advanced, you'll check the Brazilian ones.
Yeah, I think this is
Not in
cool.
high school, not in high school, because in high school they don't learn calculus.
Oh, okay. But yeah, I would definitely do this at again because these questions are cool and it's just
Sorry, sometimes I talk a lot, but
no,
it's just explaining the stuff.
it's all
Sorry.
good. Because you're typing to make the ad go away. I don't know how that works, but it's like 17 or 18 years old, I imagine.
Yeah, 17 years. Yeah.
Okay, so what's going
I don't
on
know
with
in the
this?
US, but they go to they go to first grade with 5 years old, right?
Oh, we do kindergarten and then first grade, and kindergarten's at 5 years old for some reason.
Here it's the from going from 5 to 6,
Okay.
right? A few years ago it was 7 to 8. Then they started to send kids earlier to school.
Oh yeah, that sounds late. Um,
3/2. I was reading the question.
Should I translate the question, or Feynman will do it?
I think I got it.
Yeah, we got
So
it.
we got a circle. Maybe I didn't understand the whole thing, but you got the circle radius 2.
Yeah.
The circle radius 2 is centered at the
ON
origin.
means orthonorm.
Which one?
ON, O dot N dot. It means that the scale, it's like the axis, like it's all the same side, like 1, 2, 3, 4, 5, and straight, like a 90 degrees axis. Orthonorm.
Oh yeah, like orthonormal. Okay.
Yeah, that's it.
Yeah. So a circle with center O, and I
Yes.
guess that's radius. Is it Rio?
Yes, radius.
Radius 2, and the trapezoid OCDE.
Yes.
And we know that point A has the coordinates 2, 0.
Yes.
And point B is located
Moves around.
Oh,
This-
moves around.
Yeah,
Yes, there's a
it's
key to
the
move.
sign.
Yeah.
You know, it's like the sine or cosine. That it says that it changes because of the coordinates, right? You change the sine or the cosine, and it changes the coordinates.
Yeah. So around the circumference in the second quadrant,
Yes.
and pretense, does that mean beneath?
It's like it's in that set. You know, like you say,
Yeah.
like you have the set of the integer
Yeah.
numbers. So you have 0, 1, 2, 3. They are in the set. That's what it means.
And the
So
semiplane defined by
yeah,
y is less than negative x.
yes, it's a
So
bisector. Right? It's a bisector of the
yes,
So it's like a
positive.
quarter of a plane is where
Uh,
it's moving between?
it's coming down here,
yeah,
and
yeah.
it's saying point B is
Let's say
underneath that.
yeah,
Point B is on the bottom side of that line.
yes, yes.
Okay.
It doesn't
In
go
the second quadrant though.
other way. Yeah, yeah. In the second quadrant. Yeah.
Okay.
And then it's saying, oops. And then it's saying point. Oh, now I drew that and I can't erase it. Let me erase it.
Yeah.
You can undo. Yeah.
Yep. And then it's saying point C is symmetric to point B.
B.
With regards to the
Oh.
bisector of the second quadrant.
No.
So I think what it means is
even quadrants.
the
even
2 and 4. Yeah, thank you, Pares. So okay. So this
parts.
so B and C are sort of mirror images in that
Yeah, yeah.
y equals minus x line.
Okay.
And point D is on the circumference and such
So
that the line CD is parallel to OX. So CD is horizontal basically.
yes.
And point E is in the
X coordinate.
such that line, yeah. The abscissa is the x coordinate, yeah.
It means
So
that
such that
X is different than 0. X is different than 0.
okay.
That's
And such that line ED is parallel to OY,
yes.
the y-axis. So ED is vertical.
Yes.
And
For each
for
position.
each position at point B, say alpha
Is an amplitude
in radians of angle AOB, right? So alpha is that angle AOB.
Yeah.
Such that alpha is between 3 pi over 4 and pi. So we kind of knew that because B is below that y equals minus x line.
Yes.
And
we know
determine the value of alpha such that the area of the trapezoid equals 3 over 2.
And we also know it's OP is between it's pi over 4, right? You know, like the OB, the angle, the amplitude, OB from it's pi over 4. Well, AOB is how do I say? It's 3 pi over 4 to pi, but we know OB because it's in the middle, in the semiplane, right? Did you want to understand what I mean? Like
Yeah, I was thinking of this angle over here being less than pi over 4, but we don't know what it is. We have to find it, I guess.
yeah. Because alpha we don't know it. We know it's less than it's larger. You can remove okay, if you do pi minus alpha, you'll find the angle between B and C, right?
Pi minus alpha. Pi minus alpha would be the angle under B, I think.
Yes, pi minus that. No, I mean if you remove. Okay, sure. No, because there's a tiny space between B and C. You know, the whole angle is pi. Right? Then you start removing pi over 4. Then alpha, you get the B OC, I guess, or not?
My thought was this: we could draw this line OD here, and then what we do is we're cutting that blue trapezoid into 3 exactly equal triangles, and Does that make sense? Because that's a rectangle. So that's going to cut that in half. And by symmetry, this is the same triangle here. So we have 3 exactly equal triangles there. And the area is 3/2. So every triangle has area 1/2. So this triangle here has area 1/2 here. And then that means the base times the height is 1, right? So that's probably enough to solve it, because we know that that's radius 2, right? So if I drew that triangle, OED, this is 2, I can call this X and Y. And the area is 1/2 XY, which is, so I need X times Y equal 1. Yeah, X times Y equals 1. A little smaller. And I need X squared plus Y squared equals 2. Squared, which is 4. And so we can solve for X and Y.
Oh, okay.
So what do we get? Does this come out nicely?
Yeah, that could be worse. 2√3, right? Oh no, you canceled it. Never mind.
Yeah, I canceled it. So we probably want X to be the smaller. Yeah. I mean, I think we're going to have to take the minus. So, oh, but I got to take the square root. 2 plus √3. Yeah. Based on the picture, right? What do I want? I want X less than Y. So X is going to be the minus, the way I chose it.
Yeah, I think that's reasonable.
But how do we have to find
Oh, it does
alpha.
have to be less than 2 also. X has to be.
Yeah, because of the hypotenuse.
Yeah. Doesn't it turn out that Y is the other one? I think this works.
That will make sense. No? Jed's saying? Oh.
Yeah, I'm not sure if that's true, but so let's see. Then what do we do next? We got to find alpha. Where's alpha in my picture? There's a smaller angle, theta. Yeah, this angle here should be theta. These little angles here should be theta, where theta plus alpha equals is pi, right? I think so.
I'm trying to work
Well,
that
now what?
out.
I mean, we can we can just and we can leave it as like some kind of arc cosine or something, I guess. Is that how we leave the answer? Is this the answer supposed? So I want to say, I want to say sine theta equals x/2. So this. And so alpha equals pi minus arc sine of that. I got nested radicals. Radical 2 minus radical 3. Is that? I feel like there's a way to make this look nicer.
You can sometimes simplify these. The technique is
Yeah,
really
these nested
annoying.
radicals.
But you have to like find the perfect
And then-
square that it equals.
And there's an easy way to
Oh, really?
complicate things again.
Yeah, there's an easier way.
Yeah. Like, why not use trigonometry directly? Like, you can use the formula for the trapezium for the area, and then use trigonometry directly. You know.
Oh, like express the lengths in terms of like
Yeah. Yeah.
sine.
Yeah, for sure.
So AOCDE, it's CD plus OE over 2 times, I guess DE. And we can get these lengths with trig, you're saying?
Yes.
If we use the same definition of theta, CD,
CD should be twice OE, I think.
yeah. So 2 sine theta is just OE, but we basically have 3 OEs, so we can multiply it by 3. And then DE will be, I guess, 2 cosine theta.
Oh, okay. So it's a double angle. Is that what we're getting? Because now we could write it as a double angle. Maybe that's easier to.
Oh, yeah.
Yeah.
And we know this is 3 over 2, right?
Oh, yeah, I've heard about that. Okay. So
sine of the double angle is a half. Oh, that's nice.
Yeah.
A half is going to be pi over 6.
Yeah.
So pi over 12 is theta. And if what you wrote there is to be, or I guess like alpha is pi minus theta, are we done?
Now you need to
11 pi over
to
12
figure
again.
out if you but you not to figure that the angle must be inside that interval.
I mean, these are just right triangles. They shouldn't have any obtuse angles. Unless you mean something else.
Yeah, pi over 12 is less than pi over, less than pi over 4. So I think we're good.
The result should be 11 pi
11
over
pi
12.
over 12. Yeah, because we're going to take pi minus that, right?
Yeah.
Well, that's what you
that's
said,
very-
Don. You were about to do that. Yeah.
The easiest way, well, that works, but the easiest way isn't you need to add an extra minus sign to 3 sine of 2 theta. If you add the minus sign, you're inside the interval.
Oh, we're reflecting it.
Oh, I think I see what you mean.
Or
Well, the way I drew the theta, I was thinking of it as just a little theta. So
the way we do it in
like a
Portugal,
quadrant 1 theta.
yeah. The way we do it in Portugal is like this. You have you know that Don, could you go up for a second?
Oh, like to the
Okay,
question?
over there.
Yeah.
Yes, yes. It's fine now. Okay. Okay, fine. So we have we know that we have theta, alpha, sorry. So the angle goes from OA to OB, right? We have the theta, the alpha there, right? AOB, right? The angle. That's the angle we have. So we first define the coordinates of B. So 2 cosine of alpha, comma 2 sine of alpha. Then we define the coordinates of C. Then we do some projections to get the y and x coordinate. Then we just use the formula of the trapezium, and then we get the right signs because we are using the angle as defined, you know. So if we do reflections, there's an exercise, for example, instead of B, only B, you have the reflection. So we define the point with that angle, then we reflect and get minus, for example, on the X coordinates, for example, and we get the right angles that way. It's all they teach in Portugal.
That's
So
interesting.
so it becomes easier in some sense. But it's correct. It's 11 pi over 12.
Yeah, if we want
I
to
checked
reflect
my
it.
I checked my my nested radicals. It was right. It's just not a very nice way to write the answer.
Okay.
Well, you can do that, yes, with the right triangles, yeah. They don't learn arcsine in high school, so
Oh, that's crazy.
no arcsine, no arctangent, no arccosine. Basically, the the inverse ones you don't learn it.
Oh, honestly, that might be for the better. Those things are confusing.
Yeah, and then when you get to university, you have the ones where the hyperbolic ones, and it's crazy. I was in some complex exercises. I blame Don for that because of the group reading, but it made me want to know more. So so I was doing some stuff and some proofs. It's crazy the ways we can play with it with the and we get cosine, and then with the hyperbolic ones we can go back and go further. It's nice.
Yeah, these are really nice questions, Mouse. Thank you for finding them.
Yeah,
Uh,
thanks
it's
for showing this.
I follow these professors, and they keep sending me stuff, and before they publish them they send it to me to if I want to solve it and find some errors and things like that.
Nice.
It's fun. Yeah,
Yeah.
like I said, next week, I believe it's next week, it's the exam. So they will do the exam at 9 a.m., 9:30, and some professors, they start doing their solutions, right? And they start publishing, and I go watch or read their solutions after I do it. And then I keep when I find errors and I send them message. There's an error here and there. It's fine, you know. And and they stay all day like that. They spend the day doing this stuff, like different stuff. You know, it's crazy. The the day for the exams. You know, it's the last day of their lives, right? And the beginning. No,
Yeah.
the some of like the some students they don't study for the grade. they studied not to fail,
Mm-hmm.
especially in ninth grade and things like that. Like they like I was doing a math live today, and they were asking, how can we not fail? Instead of it, help me pass or do better. No, it's help me to not fail. Like, what's the lowest grade I can get to not fail? You know?
A lot of American
Yeah,
students are like that too.
yeah, it's great. Like the one, like the grades in ninth grade goes from 0 to 5. Nobody gets a 0, and some professors or teachers, they won't give you the tool to fail, but sometimes it's rare, it may happen. So some they had a 4 and they were asking what's the minimum grade they need to pass. And the test goes from 0 to 100%, and they were saying, oh, you just need 20%, 80%. Who studies for 20%? Uh, I would be studying for the best, not for failing. You
Yeah.
know, it's great.
I want to ask about. So you mentioned you were doing a math live. I looked at like your Twitch account though, and I didn't see like a live stream that had happened. Are you actually like streaming now?
No, currently, no. It was in the afternoon.
Oh no, but like I wouldn't have cared if you were streaming net now too. But like, where are you streaming? I'm
Oh, it
curious.
was for a teacher friend of mine. He was doing the live, and we were discussing and
Oh,
solving. Yeah, I can share the channel if you want.
yeah, sure.
It's in
That'd be cool.
Portuguese though.
That's fine. Um,
It's nice. It's ninth. We're going to do 12th grade next week before the exam, but we did today ninth grade questions. The each channel has a lot of viewers for the ninth grade. You know,
okay, fair.
for these exams, you need to know a lot of particular stuff, right? Not because the problem with more advanced streamers, right? They have a situation that is they assume you already know how to do it, right? It's common, right? So you have to be careful when doing these files,
Okay.
Well, pretty good.
Yeah, unless there's anything else for the good of the order, I think we can call it there.
Sure.
Next time we need to bring Papa.
Yeah, Mouse. Feel free to let me know again if you find another like cool test. We can just go through and
Yeah,
solve it.
if you want to make it easier, if you want, I can cut some of them or clip them, and then you evaluate if you like them, if you need something more specific, or
Okay.
next
I
time.
mean, honestly, if they're anything like this, like I would have done pretty much any question from here. So, yeah, or even like
Yeah,
the
good,
physics
good,
stuff
good
too.
questions. Good questions because they weren't like they were like solvable, but they weren't like trivial. They were interesting and they were kind of challenging.
Yeah, because it makes you think, in my opinion, like I believe we are used. Well, I'm starting in university, but you people are used at from my point of view. You're not you don't solve these questions really often, so you think higher stuff, right? You think you go figure something. Maybe you're going around the block, and you just need to go straight to the point. You know what I mean.
Yeah.
It's common. Like when you study something more advanced, it's common that you lose that uh, point of view, right? You're not used to do simple stuff. It's hard, but it's at the same time it's simple, right?
Mhm.
Yeah, yeah.
Okay.
Well,
Well,
thanks for having me again.
yep. Thank you for being here, Fenlox.
Yeah,
Now, thanks again
yeah,
for setting this up.
okay, no problem. It was fun.
Yeah. And I guess I'm just gonna do some normal like math help now, but
Okay,
I'll talk to you
I'll
guys
be
later.
here.
Sounds good.
If you want, later, some other time, I can bring some of my university tests also, if you want.
Yeah, sure. That'd be cool.
Cool.
And oh yeah, Popular is mentioning Eddie Wu. He has some nice videos. Yeah,
Oh, I think I've heard the name.
he
I haven't
was
watched.
considered the best professor or teacher in the world sometime.
Oh,
Wow.
cool.
I don't know how it works, the competition, but I believe that some schools and the students choose and they sign the professor up for that competition. Then I don't know how they choose the, the winner. Right? He has some nice videos, like small but concise, right? And he is a good communicator.
Hmm.
He
I'll have
speaks
to check him out.
not too fast, even though his New Zealand accent sometimes kicks in, and there are some words you lose along the way. But he speaks slow, and it's nice to understand what he said, right? So he has some integrals questions also, and from his exams. Oh, he's asking. No, no, uh, no. I gotta be honest. Not really honest. Wim, he he knows too much. I get overwhelmed. I get really overwhelmed. To be honest, I gotta be honest.
Slim is a
He,
smarty.
every question he solves, it's too much for me. I gotta be honest. It's true. Sometimes, okay, we solved some G questions, but and I saw them an easy way, the Portuguese easy way to solve one of the questions. He even said it was memorized with the way I solved it, because like I said, he complicated too much. I saw the question. I said, okay, we just need two equations. He wrote the whole blackboard to solve the question. It's great the way you people solve questions. It memorizes me sometimes. No, I'm not trashing or anything like that. I'm a compliment. It's a compliment. uh I believe it's awesome. Okay,
Yeah.
done. I don't want to waste more
No,
of your time.
no worries. Uh, thanks
It
again,
was
both of you.
Yeah.
Yep.
There's a few combinatorics present if you need translation.
I was kind of interested in those two. I just figured they'd be a little bit too much for the translation.
Yeah, in these exams you might find what's that system? Stars and something
Oh,
in
stars and
combinatorics.
bars.
Yeah, yeah. It may have one of those over there because in
Oh.
high school, uh, in the exam it doesn't show up. They don't teach. But even though some exams there might have it because the teachers there they like to make it harder. And especially one of those teachers over there, he loves combinatorics. He might be the best at combinatorics in Portugal.
Hmm.
He loves that. He likes to invent questions and things like that, and he likes doing it. He teaches every teacher in Portugal. He teaches them, you know, and it's nice. Uh, it's good. It's good.
That's awesome. I, that it sounds pretty challenging. Then I don't know basic combinatorics, but it'd still be interesting to see like what they ask about.
Yeah, to answer to Papadorian, yeah, that's true. That some words are similar. and with some help, I believe we get to understand each other. I guess
And
it's not
apparently
hard. It's math,
Bedbox is a
right?
translator now too.
Yeah. No, it's math at the end. Like it's
Mhm.
some words there, like number 7. I believe Don can understand that easily, right?
Oh yeah. Given a geometric
I
progression
took a
that's
couple years of
monotonic.
Spanish,
Yeah.
so it helps out a little
Yeah,
bit.
Oh yeah, same.
and Don has a beard, so he understands. I have one also. I'm getting old. I do have one. Mine doesn't grow much, but I have a tiny one.
Some beard is better than no beard.
Yeah, for sure. For the in the cold weather, even better.
Yeah.
Yep.
No, like I said, they have a few good questions there. And okay, for example, for sequence and things like that, in Portugal, 0 isn't an integer unless you go to university. That's an
Oh.
integer.
Really?
Yeah, in high school, it's not an integer. It's going to be next year, but not
Okay,
yet.
that's confusing.
Yeah, that they are changing that policy. And next year you can use Hospital next year.
Oh, good.
It's they will forget about how to use the limits, but how to calculate them. But you can use it next year.
That's nice. I'm a L'Hopital's fan.
Well, it helps. We gotta be honest. It helps.
Papador is asking you a question.
Yeah. So
Yeah. Do you want to answer it?
yes, we call it whole. It's integer in Portugal.
So you use the same word for integers, but it means
Yeah.
something else.
Oh, a positive integer. Okay. We have a Portuguese word for it. Well, more than one. Like when the nomenclature, there's Z0, right? And Z0 plus, Z0 minus. I don't know if you use that a lot.
Oh,
The
for the
Z is
integers, like I
with
don't think
the
we use z0 exactly, but there's like z with the integers or with the zero removed or something.
yeah, 0, Z, because with if you type Z0 plus, it's only the positive or non-negative numbers, right? Non-negative numbers, because 0 in Portugal at least, it is included on an integer, so it can be positive or negative, right?
Okay.
So we say when we have Z0 plus, it means non-negatives. If we have Z0 minus, it's non-positive numbers.
Okay.
And answering to Point Galvis, I believe that's his name. In Portugal, natural numbers don't include 0, right? So it's 1, 2, 3, 4. It's like everywhere, right? In general, right? But you can have natural numbers with a 0, right? In some places. In Portugal, it will be next year.
Fair enough.
We have a lot of defined rules in high school because if a student is going to do an exam, they need to know that for what they are being evaluated, right? They're not researchers, right? So they don't have, I'm going to prove Collat's conjecture, right? We have to know a limit for that thing, like all things work. In a university they can change the rules, right? Like 0 is included in the natural numbers. For example, you didn't see there's an exercise. For example, I need to calculate the concativity and when the function is increasing or decreasing. You can have closed brackets or open brackets, right? In high school, uh, they define it in a way, but in university they teach you. There's always some point around the radius of that number that exists. So it's always a closed bracket, you know? So they teach you different. And then in topology, they teach you a different way, you know? So it depends, right? So that's why in high school it has to be really well defined things. You know, it's a it's a different approach.
Yeah, I can see why they might want to like take that approach because it might be simpler, but usually they end up doing weird things still. So
Yeah, true. But you know, in high school, like I believe, in my opinion, like it needs to be well defined. Or point out is the best university for math. Oh, so I'm going. It's a different. It's a difficult name. Like it's in. It's the well. Uh, Mine of doesn't have the name of a town or a city, but because we have two campi in two towns, right? But okay, the best one for math might be Porto, where's the wine, or Aveiro. You know, of course we have the okay, maybe the one in Lisbon. That's an institution. It's a private school. Um they have the best aerospace engineering degree in Europe.
Hmm.
It's really expensive, maybe the same price as studying in the US. You know, I was going to do aerospace, as I told Femvox. Coimbra isn't bad. Maybe chemistry, they have one of the best professors there. It's the oldest one in Portugal. I believe, 12th century or something like that. It's funny, since you mentioned Coimbra. Uh, it had always the same name. It was called Universidade de Coimbra, Coimbra University, right? But instead of being in Coimbra, it was in Lisbon. You
oh,
know, then they moved back and they called they kept calling the same name, which is Coimbra. They had it's crazy, isn't it? Okay, that's it. Point out IST. That's in there. No, it exists. It exists. It's where the aerospace degree is. It's really expensive. It's maybe in the 300 best universities in the world. Oh, my
nice.
university is the 300 the top 300 universities with less than 30 years. 30 years. It's Lisbon. Lisbon, not Lisbon. That's a different name. No, well, no. It's fun in Portuguese. It's not Lisbon, of course. It's Lisboa. But Coimbra, it's the same name. In my town, it's the same name in English. But it's funny that the capital, which is Lisbon, and Porto, are the only ones that they changed the name to English.
Oh, I didn't know
Hmm.
that.
Like it's O Porto with an O before Porto,
Ah,
and Lisbon. Those are the only towns or cities that they changed the name to English. I don't know why. I believe they sought out the English
Probably
language,
some
but
English dude. Yeah.
mm, we have in the south of Portugal, we have more English people than Portuguese. So
Oh, wow.
yeah, I don't know, Point Obvious. I don't know. I've never been there. It's too far to travel. It's 600 kilometers. It's too far, and it's expensive to go there from by car. Maybe 200 euro. It's better to go by plane. It's cheaper.
All right. There's a math question that's waiting on the Discord
Okay,
that I
okay,
want to
go
get
for it.
to.
Okay, okay,
That
okay.
was cool
Uh,
to hear about that.
okay, sorry.
No
I'm
worries.
leaving the Discord. I'll be here, but I'm leaving the Discord. Okay.
Sounds good. I'll talk
Thanks,
to you guys
guys.
later.
Okay.
Bye.
Okay.
Yeah.
Okay. That was really fun. Boys Mouse is just kind of fun to talk to. We should do that again. Let me change my YouTube information quick, and then I'll change Twitch information and get music going. Do. Oh no, I don't have my YouTube stuff ready. Ugh. Mouse, thank you so much for doing that. That was super cool. We need to get you on like a podcast, I feel like. I mean, I don't have a podcast, but I feel like you have a lot of like good things to like say. Okay, YouTube's updated. Twitch is getting updated. Okay. Earn decoding. Oh, I assume that's for Papadoria. If it was for me, then the answer for me is also yes, but not super into it. My lifelong dream of having a podcast. I'm not a very talkative person. I don't think I'd make a very good podcast like guest or host. So Papadoria asked a question in the Discord. Actually, well, there's kind of two Papadoria questions. One is there's a revised version of the question he asked the other day, but there's also this one about Feynman's technique. Okay. Um, yeah, it's like a Gaussian, but the cosine makes things weird. Oh, is this a way to solve the Gaussian thing? The Gaussian integral? Leibniz rule? Maybe. Can't remember what that is. Papadoria, are you here? Maybe I should ask that first. I'm kind of guessing that... I don't want to guess. Oh yeah, point guess I saw it. I feel like that's a pretty common thing, like Spain versus España, Germany and Deutschland. I guess not all of the countries do though. Oh, you are here. Okay, good, good. So the Leibniz rule does seem relevant here. We translate all English names to Portuguese. Really? Oh, well, I mean, that makes sense. Like, United States in Spanish is Estados Unidos. Nova Yorke? Hey, Silver, land of the Deutsche Volk. Oh yeah, a spy from TF2. I don't know why you're always talking about the Davy Crockett stuff, but I couldn't properly say welcome because I don't want to cut off the conversation, but welcome in. TF2 is an awesome game. Yeah, I mean, I guess we could have asked them to just like join us today too, or make it a collab or something. But always just like bring more people into these. Oh yeah, Loki, if you want to start coding and from scratch, that's one of the weird things where I don't have a very good answer, and I feel like there should be. I had different computer science classes that I took, which is how I got my, well, the real way I got my start is I was a kid playing Roblox and I really wanted to make my own levels, so I learned the coding language they have. But I learned it better from the computer science classes that I took. If you're just self-studying, it's kind of difficult to learn the basic concepts. Like, I feel like people just start talking about the language itself. You made a CPU in Minecraft? Oh, wow. Got some dried mango from the store the other night. It's delicious. Is it like flavored mango or just regular mango? Yeah, or at least I don't know what Roblox itself is made in, but for the people making, like the users who make the levels, you do that in Lua. It's like it's their own version of Lua, but it's basically Lua. Okay, so what's up with this? Oh, wait. Interesting. Lua is moon in Portuguese. Oh, really? That makes sense. Plain dried mango. Bought a bunch of times for using this bag is outstanding. Huh. Okay. Because I've had like spicy dried mango, and that's good, but I can't eat too much of it. Since learn Python my first language, I gave up. I think I'd rather do better in formal setting. Yeah, Python is kind of it does so many things for you that I feel like as a first language to learn, it almost kind of, you don't learn the things that you need to learn if you want to transfer it to any other language. Like I learned on like Java as my first like real language, which makes you do more things manually and learn a bit more about how computers actually work. Yeah, I'm sure there's like a million YouTube tutorials out there, but like I never looked at a specific one. I know it's kind of a weird thing where there should be a million things out there, but I haven't really found a satisfying one. Java's the epitome of classes and classes, yeah. Lua was invented in Brazil. Oh, cool. Yeah, and even then, like you say, silver pills. YouTube tutorials aren't always the best. So yeah, Papadori, for the first part of the question with integration and differentiation, I don't know the reason why this works. It's probably not an easy proof. Yeah, there's a fundamental theorem calculus step happening in here. What? I probably could understand this, but it's a little bit. I'd have to do a lot more thinking about this. Hand wavy, but sort of in-depth English proof. Need to explain to your little brother who doesn't have much experience with a formal math proof. The hand wavy proof that probably is not ideal is that let's see, d alpha integral 0 to infinity e to the minus x squared cosine alpha x dx. The hand wavy proof is that integration is just a fancy summation. Some type of limit as like you know, this is the definition of integration more or less. And the derivative, like this limit has nothing to do with alpha, so the derivative can come inside that. This summation has nothing to do with alpha, so the derivative, or actually, I mean, this is just a summation, and so the partial derivative can just come all the way inside of that. That's probably, this is very hand wavy and probably it's not ideal, but that's kind of the thing that comes to mind for me, at least, as a sorry, I guess the f of x here is that thing there. So that's not ideal, but like I wouldn't want to go too deep into whatever's happening on the Wikipedia page. It's probably not that bad, but I would need to spend a lot of time understanding the proof they give and then spend even more time trying to figure out how to like explain it simply, and it might not even be that simple, so I don't know. But you can mix chili pepper flakes with your coffee grounds before brewing. What? Ew. I mean, no. No, I don't think that doesn't sound good. I was trying to see if that could be, I was trying to imagine if I could like that being good, but I don't think I can. So that's maybe the first part of your question answered. I'm not sure I understand like this question here. Was that still about the thing that I just explained, or is this a different question? Why we treat DFDA as a fraction? I think you can explain that part to him, knowing it has connections to Leibniz rule. Okay, cool. So yeah, the deal with DFDA, or D alpha, it's not a fraction. It's more like a metaphor for fraction. For taking two infinitesimally small quantities and dividing them. But like the definition of DFD alpha is that like limit definition of a derivative. I'm getting confused on this. There we go. And so it's only a fraction as far as this thing is a fraction. But as it turns out, as far as I know, in basically any situation where you want to pretend this is a fraction and multiply something by like d alpha, it actually works. You have to prove it separately, but it happens to work out and act like a fraction in basically every single way. It's a really confusing thing that I probably don't understand as deeply as I could. But that's how I think of it, where it's a metaphor for a fraction that happens to behave like a fraction in almost every way that you care about. Can you play the drums now? Me? No, I sure can't. Or do you mean Fembucks? But yeah, so like this being a limit is why you're not supposed to just treat it as a fraction, because you can't like multiply each side of. You mean at Fembucks? Oh, okay. If this is equal to something L, you can't multiply each side through by H and like cancel these H's or something like that. So yeah, there might be a better explanation for it than that, but that's kind of how I think of it. But yeah, does that help? Did you want to ask anything else about this? No worries. And sorry, I assume the YouTube chat is still on slow mode, so I know it can take a second. And I saw that your professor apparently got the other problem wrong. I feel like I don't know. I'll put up the revised question in case someone wants to take a look at it. Think you're good? Okay. Someone is on? Okay. Yeah, so, sorry, I might try to turn it off again. It's just, there's a streak of people behaving really badly. You know, someone at least helps people who are like spamming. Messed up her one, but also added parts B and C. So I feel like I just don't know how like I still don't quite understand how Zach got the answer that he got. But I just want to show the problem here in case someone wants to think about it again. Oh, I mean, it hasn't been recent, $10. This was like a few weeks ago that I turned it on. I think Papadoria knows how to do the integral. I think that's what this work down here is. It was just a few parts of why why Feynman's technique works. I guess the answer for part A, we could use Zach's answer. If I had just like blindly trust it and not think about it for myself. Like A1 would be root 2 over pi. Hey, noob driver. Loki, this is like a challenge problem. I wouldn't feel bad if you don't understand it. I don't really understand. I understand what the question is asking. I don't understand how to solve it. So don't feel bad. Papadoria notoriously has difficult problems. But yeah, the thing I really don't understand about Zach's answer is the claim that AN equals that. I should go back there and watch the VOD because I wasn't able to hear him explain it verbally. Yeah, so it's a double factorial. So like that means you only do evens or only do odds. So 7 double factorial is 7 times 5 times 3 times 1. 6 double factorial is 6 times 4 times 2 times, I guess not 1. The one doesn't matter. Um, how does the +1 change things? I guess let's start with, I guess we take a sub 1 equal 1 again and see what happens. Uh, 2. Three over 2? Three over 2, or no. 3 plus 1 is 4, divided by 3 over 2. 8 over 3. Five divided by 8 over 3. Maybe I shouldn't be doing this. I should do this slower. I shouldn't be actually multiplying these numbers. And I should be keeping A1. There we go. That's more what I should be doing. A4 is 2 times 4 over 3 A1. A4, A5. Okay. So here comes the pattern. So we're getting really similar behavior, it seems. It just starts later. Well, it starts later, but the thing we're losing is the 1. So honestly, for I plus 1, it might just be the same thing. Oh, it does flip A1, but either way, we're dividing it out. Oh, huh. I guess so, yeah. I still don't understand. Yeah, I mean, that's the piece that I'm fuzzy on, like, how Zach can justify keeping A1 on the bottom there. for an. Noob driver, this is like a very difficult sequence question. Like you could call it like real analysis, I guess. Yeah, like we could do you could do like an a1 to the power of -1 to the n+1, I guess. Because when it's even, a1 goes to the bottom. And when it's odd, a1 stays on top. Is that what Zach did and he canceled them and just didn't say that, I wonder? Or so he didn't write it, maybe he said it. When I is odd, a sub I times I? I'm not sure where that's coming from, Poison Mouse. I think I'm going to make the claim that this one is going to be the exact same thing, except A1 is going to be flipped, like Fembox was saying, though. And this might be a way, like, I think you can say something about the powers, or the A's canceling to justify that. Yeah. And so it should all work out to be the exact same, except the A1, the same base, and so the powers add. This is so weird to -1 to the n+1 plus -1 to the n+2. These are always opposites, is maybe the important thing. You're back? Okay. The way I want to deal with the A1 flipping is to do that. A1's the -1 to the n+1. I'm trying to verify that works out on the limit. You think Zach missed 2 factors? Really? I don't see what he would have missed. I'm working on it. Like, this is weird to think about. Because isn't this just always 0? So did I do something wrong? Oh, you know what? Hmm. Should it be a negative n plus 2? Because I divided by that? I think maybe that's it. I don't think that... Does that change anything, though? For even 2n... I think... Oh, yeah, and so... Oh, sorry, Poison Mouse. The thing I've done up... I'm working on part B, where a sub I... I'm working with that definition. What Zach did down here is with the original version of the problem, where it just equals I, not I plus 1. That's why it's confusing. Yeah, sorry. I forgot about that. Oh, and actually, that means I did this wrong. I need to flip these, don't I? Well, no, I still don't get what's up with the flipping. Wait, no, the entire thing needs to flip also. No, I don't get it. I don't think I can do this. Or you might, you could probably do the entire thing to the -1 to the n plus 1. Or maybe not plus 1. I would need to think about it more, but the entire thing needs to flip also. I need to go back and look at Zach's recordings. I don't know how he dealt with that. So yeah, I'm sorry, Dory. I might need to call it quits on this one though. Okay. I feels like there's something here, but I just can't quite pull it together. There was a complex question I was working on last time. And I meant to do it off stream, but I just didn't really have the brain power. So let's see if we can get it done right now. So I think A was easy. It was just 0. B turned out to be a lot of work, unless I was doing something wrong. Oh yeah, collar cone. Completely fluent. No, apparently Fenmox is. He was like doing a pretty good job of translating them just by reading the math. Yes, someone might take another stab at it. Alex is coming to Portugal. That sounds nice. But if you had to open a tutoring center there, you'd be set. C2 was about pi. Tutors here make tons. Oh, nice. Well, now I want to go to Portugal too if tutors make tons of money. Retirement gig? That sounds nice. 50 euro an hour a lot? That sounds like a lot. Yeah, that just is a lot. I mean, in my area, if you have like a PhD, I've seen them charging like $200 an hour. That's like the high end though. I bet if I advertised locally, I could. I might be able to get away with 50 an hour because I live in an expensive part of the country. For sure, yeah. Here's where I got stuck on the problem. Because I wanted to say this is the power series for E, but it's not. That extra J kind of ruins it. Do you speak a lot of languages, Silver, or just mean like English? Oh, for Papadorios? You, your English is way better than my Portuguese, so I can't complain. English and some Deutsch. Oh, nice. Um, I'm not sure if it does Territar. As I can't think of a way to use it, but it's interesting. I kind of expected it to be increasing. What does that mean? Pee while sitting? Sits Pinklers? Oh my god, you can even see it. Sitz Pinklers. Oh my God. John Green. I don't know who that is. Mississippi English. I mean, there's some cool southern accents. Oh yeah, the German words can get kind of crazy. You just kind of take existing words and mash them together. Oh my God. What is that? The guy from The Fault in Our Stars? I don't think I've heard of that. John Green, the inventor of Green's theorem, even though it's spelled differently. Blood Brothers with Hank Green, Psycom King. Huh. Beef labeling supervision duties delegation law. Oh my God. There's no way 3 is supposed to be this hard. It's a novel. Oh, interesting. I see Dawn in there. Is that some type of insult? Will Google Translate know what to do with that? Let's see. Oh, it doesn't know. Danube Steamboat Electrical Services Company Subordinate Official Association. Those Germans sure dislike white space, I guess. Or like blank space. Why would they give us an integral this hard? If you're friends with in the IRC math channel, that's what they could come up with. Hank has also written 2 books, a series of 2 about weird internet fame and an alien landing on Earth. Okay. So what happened here after my substitution? Oh, there's a lot of cancellations. Okay, sleep well, Mouse. It was good to talk to you. Finmux needs his supper. It's about that time for him. So where's the J in the denominator coming from that I don't like? Snacking on peanuts. Ooh, nice. the initial integral. Okay, the 1 over ij came from actually doing the integral. Wait, did I not evaluate theta? Oh, maybe I didn't do that for a reason, because it was coming out weird. The original problem is here. I'm on part B. And then my idea was to deform the outer ring around z equals pi. And then you get this weird, I don't know what to call that shape. The integral it's just kind of complicated though. So wait, if I did evaluate, I kind of ignored this in the next step. Wait, is theta from 0 to 2 pi? Yes. What theorems do I know so far? It's a good question. So in the reading group, we have gotten up to Cauchy's theorem, or Cauchy's integral formula. I think this particular problem is from 2.5 that we're... Okay, yeah. It's from 2.5. And 2.5, we have Cauchy's theorem. And so I used that for two of the smaller integrals I got along the way. But when you have the poles or the non-analytic points or whatever, you get some non-zero things that I'm trying to figure out. What else do we have? Oh, I don't think that one's going to be relevant. You know, I wish they showed a second example where you do have to deal with the annoying point there. Because that one also has the e to the z on top. Residue theorem? No, I don't think that's until chapter 4. unfortunately. Yeah, that's like that's far in the future. Okay, I think they're saying to use the power series. It just doesn't. The way that I did it, I didn't get anything particularly clean. I don't know. This one might be a Googler. Oh no, Territar. I wonder, do I need to take another approach? Like, should I do a different substitution in that stage? Maybe instead of doing a substitution. Should I just immediately go to the power series for E from this stage? Sounds good, Papadoria. I'm not sure if I will be, but potentially see you then. Thank you. Well, okay. Can I... For, like, from here, can I say this RE to the I theta is Z minus pi or Z or something? Before I actually integrate? Actually, no, or from here. But then what would Z range from? I need to evaluate Z somewhere. The integral's definite. I don't know. Would it be instructive to try part C? Just skip ahead? I feel like C should be, I feel like B should be something simpler than what I'm doing. I don't know what it should be, but like not this hard. You know what? No, I want to Google it. Nope. Not. Ha. Without the residue theorem. This person is doing part C, I think, but this might still give us some insight. Yeah, they're using residues. Ugh. I don't know how the book expects us to do this, then. Yeah, I did the partial fractions. I think it's how I went from that step to that step. I think it's the same thing as they got in the stack exchange thread. Oh, did I flip a sign? Split them up into two. Oh no, I don't think I flipped a sign. Right, and so I think that's what I was like trying to say with this. Like if you split them into two integrals, that second integral, or if C2 doesn't include pi, which it doesn't. Come on. I just undid something that I don't know. If C2 doesn't include pi, then that one's going to go to 0. Good news, everyone. It's able to solve the problem 872, the one you're working on stream. Nice. Really, color code? I thought we would have to. Okay. Let's back way the heck up then. After seeing the stack exchange, I want to verify my partial fractions because the stack exchange thread has the sign flipped. and that makes me nervous. It did all things I did on stream are not using the solution. The problem's pretty fun as trees. Okay, z minus pi is the positive one. Okay. So I didn't mess up. I don't know how the second change thread did it differently. Okay. So first step was the partial fractions. E to the I z pi z dz. Z minus pi. Yeah. dz. So I think that's what we get after the partial fractions. And it's hard to take my mind off decomposing, but Cauchy integral formula. Okay. And so I'm down with that because I don't know how the book intends it. I think they intended some other solution, but I can't figure it out, so I'm definitely okay with just Cauchy integral formula ing. I also want to practice with applying it because it's kind of weird. Spice rack, cinnamon. Oh God, Fembox. I don't know. I don't like adding things to my coffee, so this sounds crazy to me. Oh, so kind of funny. And if how I represented here, zeta here is the z here. And that z is pi. Some star anise too. Oh no. So 2 pi I times 1 over pi to remove that factor there. And then it's e to the I pi? Is it that simple for the first part? Wow, okay. And then I guess we would consider it 0 or z minus 0. Oh wait. Yeah. Huh. Anagram circle of radius bigger than pi. Okay. So then about the second integral, it's like we're enclosing it twice. Like the pole there is at 0, and both the inner boundary and the outer boundary enclose that. Do we have to care about that? That's been kind of a source of confusion with the annulus thing. Like, it seems like mathematically you kind of treat it as one boundary, but they're not really connected. Give us the same value twice. So should I be multiplying this by 2? Oh, wow. What a crazy formula. Okay, so how does this clean up then? Think of the math. Okay. Because like the book that we're reading from will just say integrate around the boundary of the annulus and mean both of these boundaries simultaneously. And that they seem to justify that with like crosscuts and stuff, but it's just kind of weird. E to the I pi is -1, so -2i, +1, -2i, so we get -4i. Oh, sorry, no, I forgot the extra 2. So -6i. Okay. Then now, does the book say the answer to this one? 2.5, number 3. B is -2i. Number 3b. I'm trying to avoid looking at the other ones. So I did something slightly wrong. Did I make a sign mistake? Like if this was positive, I would get the right answer. I don't see a sign mistake. I don't know. Unless I messed up the partial fractions or something. But I checked it in Wolfram. I don't see it. I don't know. I can just claim that the book is wrong. Um, it is 2.5 number 3, right? Yeah, I don't know what to think about that. We can just try part C though. Let's get rid of this garbage. It was not working out. I did something I shouldn't have. No, I'm okay. Get rid of that too. Tom's, these are contour integrals in the complex plane. If all you've taken is a normal calculus class, this is gonna look crazy. But you can do integrals with complex numbers. You're still on U subs. Okay, yeah, this is crazy. The basic idea is that if you continue learning calculus, you'll eventually learn that you can integrate in multiple dimensions. It's like you can do a two-dimensional integral, whereas you're just learning about one-dimensional ones. And if you go even further than that, you can do integrals with complex numbers. And that's what I'm just learning about here for the first time. Okay, so for part C, we need to integrate around a circle of radius r where r is greater than pi. Well, that just feels like what we did right there with Cauchy's integral formula. Take A level further maths in the UK. You don't think we take integration that far? No, I don't think you would. I've seen some A level further math questions. And I don't think they'll make you do this. Wasn't the answer? It was minus 4i. Like, I can just use Cauchy's integral formula for both of these. What orientation are they using on the boundary? That as you walk along the boundary, the inside is on your left. That's one that I've only ever seen that convention. First time I was introduced to contour integration was the inverse Laplace transform. Oh god. I was just taught the formula, I think. So yeah, this is like how they do annuluses. Oh, is that it? Oh, I wasn't showing the textbook. Uh, the left is inside, yeah. Like that. I do, yeah, you do have to reverse the inside one. Is that it? Should I actually have gotten 0 for the second part? Yes? Okay. So that explains the minus 2y thing then. Ah, okay, so it's because one of the analytic points, there's two analytic points, and they're being enclosed in opposite directions, so they cancel. That's okay. Because like when the side circle doesn't change anything. Okay. Now for part C, we're enclosing. It's basically, part C is basically what we had here. Is it not? So we should just get 0? I think so. No, it wouldn't be in opposite directions. No. Now that 0 will be a 2 because it's going the same direction. Or no, I should start. Let's start with this again. So with this integral, we're doing it about a radius greater than pi. So for this integral, it will be non-zero. There's only one non-analytic point after doing the partial fractions. For this one, oh wait, no, sorry. This one is also non-zero. Yeah, okay. Because we're still including, yeah. Okay. 2 pi I times 1 over pi e to the I times 0. That'll be minus 4i, and I think that's what the answer was. And then for the last case, one of the integrals will zero out because we're no longer enclosing an analytic point. Okay. So this one zeroes out. This one will be the same as ever. Uh, 2i. Okay. Nice. Thank you for the help on that, collar cone. Um, let's grab another one. .53. Okay, so let's get one from 2.6. That's where they actually introduced Cauchy's integral formula. So I imagine a good amount of these will be quick. Unit circle centered at origin, and f of z is the following. They want to see the power series for E for one or both of those. Two pi I sine of 0. Yeah. So 0. That's lame. So if we did cosine of 0, or if we did it with cosine, we would get a non-zero answer. The first one, it is analytic at 0. Really? I mean, I guess it would have to be because this implies that it is. We do have that theorem. Well, it has to be every loop. It's a bit like z over z. Okay, I can imagine that, yeah. Sinus has a 0 of order 1 and 0, so it cancels out with the z. Yeah, I guess that series argument is a good one. So we have an analytic point at 1/2. And we are enclosing it because it's the unit circle. But as it's written, this isn't very conducive to Cauchy's integral formula. A pole, right? How do we fix that? Or can we say... No, I don't think we can. This one. Okay, so it's just going to be 1. We have to do some messing around to get it in the right form. Oh, 2 pi I. 2.6.2? Oh. Didn't really think about that. Okay. So k plus 1 is 2. So this will be f1, which I always get confused with derivatives with this notation. I assume that's the first derivative and not the 0, like no derivative. So basically f prime of z times 2 pi I, and k is just 1, so who cares? And f, this is f, wait, ooh. Okay, cool. Thank you for confirming that. We need to be careful with this coefficient here. We should factor the one, we should get the 1/2 out of here before we try to apply the formula, maybe. So we're gonna factor a 2 out there. It gets squared on the way out, so it'll be a 1/4. And so f of zeta is just 1. But this is the derivative, which is 0? Digging this beat? It's called Hot Plates by Judge Bitch. What the hell? Zero's expected? I thought we wouldn't get 0. Or like F is, I guess it is, but actual cinema. So do you always get 0 when integrating around a pole unless you have a more interesting function in the numerator? Reaper, hope you're doing well, dude. I was thinking of Congressman. Instead of Judge Judy, we have Judge Bitch. Okay, 0 feels lame, but 1 over z, compute the winding number of times your curve winds around the origin. Oh man, I haven't learned the word, or I've heard of winding numbers, but we haven't gotten to them in the book. I don't know. Depressed planet, is every continuous function Riemann integrable? Why or why not? I would say for finite bounds on the integral, yes. I can't imagine a situation where you have a continuous function. You can make it look as funky as you want, as long as you don't lift up your pen. Like, there's no way you can't draw rectangles underneath this thing and add them up. The only thing where you could get, well, yeah. The only way you could get tricked is if, like, this wouldn't include integrals to infinity. Or at least you wouldn't always get convergent integrals. But as long as your bounds are finite, like from A to B, I think continuity is good enough, yeah. And when you say why or not, if you're looking for an actual proof, I would need to do some Googling. But that's the intuitive explanation. Views effect a lot when doing topology of a surface. Okay. Use on a compact interval, closed and bounded. Okay, right. No worries, planet. So yeah, it's kind of funny where derivatives, you need extra things to be true, but integrals here, okay. Bounded is not enough if you drop the closed hypothesis. That's no longer true. And that's because you could have like an asymptote if it's not closed. Like it's technically still continuous. Okay, yeah. That always trips me up. Like when I was taking like last year Zach taught like a real analysis class like live on Twitch and I took it. And for one of the problems that he assigned, I was trying to use one of just about like how to prove things are continuous or something. I was trying to use 1 over x as a counter example, and it kept not working, and I couldn't figure out why until eventually that explained 1 over x is continuous, just only where it's defined. Like, oh. So that always like weirds me out. Kumar, number of solutions. Are those powers? I guess not. Those are indices. Rihan, oh, awesome. I'm glad to hear that. Well done. U equals tangent x. Ooh, cool. Kumar, I'm not sure, like, there'd be infinitely many. Oh no, if they're with those restrictions, maybe not. This is what I'm looking at. This feels very, this feels kind of difficult to answer. So I'm going straight to Google. God. Uh, this is breaking my brain. Oh, that's kind of clever. Huh. Wait, are these binary numbers or just literally ones that were... You would add them up. So this is... They're more like tally marks. Wow, that's a crazy argument. Okay, I kind of like this. I assume the answer you're saying is going to be the same as this in some way. This answer does have N and M switched. It looks like what the stack exchange answer is saying is you write M with tally marks, which I would never think to do in a math problem, but like, you know that M can be represented just by adding up a bunch of ones, basically. And you can think of these X's as just ways of splitting up these tally marks. So we can place addition signs anywhere between these ones. So there's M minus 1 many places that we can put addition signs. And then the number of addition signs we have to place is n minus 1 because there's n variables, so they're added n minus 1 times. So it's m minus 1, choose n minus 1, I believe. Yeah. And so you're saying the answer is n plus m minus 1, choose n? Oh, wait. No, you're saying it... Sorry, you're saying the answer is n plus m minus 1, choose n. I bet there's some combinatorics identities that make these things equivalent. And that you could get to the other one naturally with some other train of thought. I guess it looks like this one right here. So, like, we already answered the question with what I said, but just to show that these answers are equivalent, I'll try and get it in the form... Ooh, wait. There's way too many letters here. N is the same. K is 1, J is M. That doesn't make sense. I think there's a way to mess with these to show that they're the same. It's not immediately clear to me though. So yeah, Kumar, I think we have the right answer here. I'm not trying to get the form that you say, but if you want, I'll link you this and you can like read it for yourself too. Below, good websites for learning math, even if subscription based. It probably depends what type of math. No worries, Kumar. But general things I can recommend. Well, first off, I should chill. Paul's Online Notes is great for calculus. But more general things. MIT OpenCourseWare. They have an accompanying YouTube channel where you can see actual MIT lectures as well. So I've gone through all their linear algebra, and it was pretty good. It wasn't perfect, but it was pretty good. These are all going to be free because I don't know anything about subscription-based services. There's OpenStax, which are textbooks that are completely free. They tend to be on the for math in particular, they only go as deep as calculus, but they have a bunch of stuff that's like before calculus. So depending on what you're planning on studying. Like they're good for like the earlier math. If you want to go deep on math, there's the open textbook library, which has free textbooks that are used in universities. So I've grabbed one like a Calculus in Context off this site. Is a good one for applied calculus. The last thing I have to recommend is Oxford publishes all their lecture notes. I haven't gone through any for myself, but you can see actual Oxford lecture notes for like maybe all their classes or a bunch of their classes, at least math. Oh, String is a calculus book? That's nice. I went through String's linear algebra stuff. The Stack project? What is the Stack project? See it below. I hope that helps. If you don't want to say anything more specific, maybe that'll ring a bell, but those are the general kind of math help resources that I've at least looked a little bit into. Vouchering is like, you should be able to take some steps back. Yeah, at least for his linear algebra, it's supposed to be an introductory class. I don't think I would have done well if I took it as my first linear algebra class, though. He moves quick. I do like his style though. Like I feel like he'd be a cool person to like talk to. Hey Luke. Okay, for part C in this question, how is it any different from the last one? Aren't we still going to get 0? Collaborative book on stack theory from scratch. I don't know. Oh, I never heard of stack theory. 8,000 pages of graduate math. Wow. It's crazy. Section 1.1 does the main ideas of both differential and integral calculus just using sequences. Good stuff to accompany traditional text, even if it's not your main one. Wow. Section 1.1. That's a lot. The fundamental theorem in 1.1. Yeah, I guess like Paul's on my notes, like it's kind of the opposite. Like for if you're trying to learn calculus, they skip over all of the theory, which I personally really like because it makes learning it for the first time. I said for me, it helped me learn a lot the first time because it taught me like what to do for the problems, and as I did the problems, the why of it kind of sunk in naturally. I'm nervous I've done 1B wrong. I don't like that I'm getting 0. .6 1B. It is 0. Okay. That's so lame. Give okay. So that means the next one is also 0. Why would you ask C when you've already tested that knowledge in B? I guess I am color cone. The thing I'm really questioning is what is the point of including part C when there's not a single difference in reasoning from part B? There's no reason to include that in your textbook. Ugh, okay. Dang it. I shouldn't have put that problem there. Okay, so e to the z over z. Now, well, as is typical for this textbook, they're suggesting I use the power series for e. Do I actually need to do that, though? Can't I just go straight to Cauchy's integral formula? With some complex integration, more about counting the number of poles and computing derivatives than doing complicated tricks. That's good. Two pi I times e to the 0. Why would they want to use the power series? I really don't get what the book is after, trying to use the power series all the time. Oh, this is e to the z squared. That might need a power series. Okay. Off to dinner? All right, enjoy, Dr. L. Seems like complex numbers are easier to work with than reals because they're more complete. Square root of any complex number is another complex number. Oh yeah, there's less to be worried about in that regard. Wait, I can still use this. Yeah. I I feel like when this book says to use a power series, I don't know if I should listen. Okay, so this is gonna be the first derivative then. So 2 pi I, k is just 1. Derivative e to the z squared is that's gonna zero out. I'm gonna call that part lame. E to the 0 squared times 2 times 0 minus 2 pi I. Now this time it's 3, so that's 2 over 2 factorial. The second derivative, I need to do this separately. Product rule. Okay, and then we're evaluating that at 0. The contour is the unit circle, right? Yeah. But anyway, like going to the power series seems it's probably possible for this one. The one of the z minus pi. I don't know how the hell that was supposed to work. You're reading the theorem. Oh no, yeah. This evaluated at 0 is just 2. So we get minus 2 pi I. Noish. Circle. Yeah, as long as it encloses it, that's the important part, which is weird. But yeah. Okay, how many zeros are the answer for number 1? 1, 2, 3, 3, I guess. 3 out of 5 are just 0. But let's check all of these. Zero, 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 2 pi, minus 2 pi. Hell yeah. Okay, the only other one that I pulled for the reading group that we didn't have time for. Wait, why are you a blank page? Okay. Oh yeah, so this one looked interesting because I've always wondered how you apply. Well, this isn't a real integral, but like how you use complex variables to help solve real integrals that are otherwise very tricky. But I just realized that this isn't quite a real integral because that's I. Closed semicircle in the upper half plane with corners at z equals minus r, z equals r plus the x-axis. So you need a clever contour? Oh, okay. In an entry exam for some reason? Oh god. Okay, so the contour is going to be that bad boy, oriented like that. Radius large R. And so as long as it depends what R is going to have to be more than 1 in order to enclose that. You don't really care. Yeah, right. But I mean, I'm trying to figure out why R going to infinity is important. Oh, because it mirrors the original integral? So is x a real number? I guess it must be, because this doesn't seem very well defined if not. Oh, okay. So the idea is this lower contour, that just is the minus infinity to infinity bounds in the original integral. And by showing this, we're going to prove that the lower part of the contour is equal and opposite to the upper part of the contour. But the upper contour will be easier to evaluate, I think. That's probably why we want to do this. What a champ. I mean, I have to actually do it now. Oh wait, this is C1R. I thought this said just CR. Brother, we can probably just calculate it for C1R and worry about what it means in a minute. So we can parameterize it. Because C1 is just the semicircle part. So we can take z equal to r e to the I theta. We're going from 0 to pi. Hey, Empire. Oh, maybe I should say z plus I. It kind of depends on the person, Empire. I can definitely tell you it comes down to doing a lot of practice, but how much practice kind of depends on you. You don't really want the value, you just want to show it goes to 0. How do you pace it? I mean, for me personally, I just kind of keep going until I feel like I get it. But a lot of people will do it like structured, like 50 minutes of studying, 10 minutes of a break, and they'll do that for 2 hours a day or something. But I don't usually like doing things that strict, but that definitely works for a lot of people. I mean, the integral is probably too hard. ChatGPT it? No. Why would it go to 0? I don't really have intuition for this. Get a parameters to see what's going on. Okay. I mean, it might be possible though if I say z plus I. I was. Oh hey, Papadoria. I guess I ended up streaming long enough. But then that screws up the bounds, doesn't it? I don't know. I don't think that's legit to say z plus I. I don't really know. Oh wait, this is no circle here. So if this is open, we're not enclosing an analytic point? Can we actually just integrate this like it's a normal like Calc 1 problem? Yeah. Uh, or I mean like, since the contour doesn't actually go through the analytic point, can I just say it's like put a negative 1/2 z plus I cubed? Because they're talking about C1R, and C1 is just the open semicircle up top. So that's why I'm thinking like it might be okay to just do it like that. I'm gonna be starting on a master's in just like 3 months. Empire. So I don't know. I hope that's legit. We haven't enclosed any in non or poles. Uh, applied math. And so this would be 0. I hope I got it in a legit way. I have a bachelor's in applied math and a minor in computer science. So why is this helpful? What job can you get in math? I don't even know, dude. I'm just doing it because I like it. I'm not doing it because I think I'm going to get a job with it. Minus r plus I and r plus I. In the denominator? Did I reverse the signs? Don't we do the upper R first? I mean, I was just thinking, like, I was just taking the limit at this point. I wasn't necessarily canceling them. Or like I was doing like individual, like that goes to 0, that goes to 0. Okay. Scary looking math. Yeah. Can a bachelor engineer do problems like this? Depends on the type of engineer. Maybe electrical, or maybe like if you're dealing with fluids. I know, I'm not sure exactly where this is applied. Electrical, maybe. I don't really know, but I know that electrical engineers learn about complex numbers in general. I don't know if they need to care about integration. It might just be like differential equations and complex numbers that they need to know. And so if we know that, oh, is the, okay, so maybe the point here is this should be path independent. So the path we actually care about is this one here. Neither of the paths go through, I guess it's negative I. This entire time I thought it was positive I for some reason. Negative I is the important one. And so because of that, these integrals are path independent. Well, no, wait. My argument is, I think I made a mistake with my argument here. I could have done this exact same. I think I just actually integrated along this path here, or the path doesn't actually matter. Why can't you just integrate this directly? Yeah, I just this question seems kind of silly the more that I look at it. Yeah, I agree, Colorcom, that this I don't think it's a very good question. Ugh. Do I like olives? I want to like them. Um, I usually don't like them though. Like I like them on pizza, and this one restaurant that I've been to has olive bread that I really like, and I like olive oil. Outside of those things, I don't really like olives. I wish I did though, because they're really healthy for you. I even tried to make my own olive bread, and it just didn't come out good like theirs did. Olives and drinks. I never actually had an olive in a drink. Spin parts problem for masters hard to find. Like a little bit harder, but you can always like. There's always a bunch of textbooks. On whatever subject that you want. No licorice, no olives. If you tell me you don't like fresh tomatoes, I may have to consider unfriending you. Fresh tomatoes are great. The tomatoes at the grocery store are shit, and I generally hate them. But a nice fresh tomato is great. They should also generally be sliced on the thinner side. Once you get too thick, it gets too mushy and too watery also. But yeah, color cone. I don't like 3, I guess. Grocery store has good tomatoes. Nice. The ones that my other grocery store I've been going to recently are like okay, so I buy them sometimes. Does math have politics? At like universities, professors are always. I mean, anytime you have like an office environment, people are working together, people are going to be like screwing each other over. So in academia, there's definitely like politics, if that's what you mean by that. Got some green olive stuffed with garlic. Nice. Like it kind of sounds good, even though if I actually ate one, I probably wouldn't like it. I don't know. I have a weird relationship with olives. I don't think you can, Empire. No. I'm kind of annoyed at this book now. Oh my god. We need to have a counter for how many times they tell me to use a power series for E. Ooh. Let me see, what color cone put. Honestly, I'm getting a little bit tired. I think I might just wrap it up for the day in a few minutes. I'm dealing with a similar problem. Oh yeah. The book showed us this somewhere. Yeah, when it comes up, I guarantee you I'm not gonna think to use it. But hopefully with you sending me that'll give me a little kick to try and remember that. I remember reading that in this book somewhere. It's not important. All right. I think maybe we'll call it for the day. I got through the complex analysis questions that I chose, even though it turns out I didn't choose very good ones. Ooh, okay. But yeah, it feels like it's about that time. 4.5 hour stream. It's a good stream length. Yeah, Empire, I usually kind of skim through the problems and try to find ones that look interesting. This book doesn't have very good problems, though, it seems like. Not all of them are that good. So yeah, problems do I do per day? I don't do a set amount. I just kind of set a goal for myself to understand this thing. And I just kind of keep on working on it until that happens. But yeah, on that note, I'm gonna cut the YouTube stream off here, so Empire knows who's here on YouTube. Thanks for being here. And I'll be back on YouTube in 2 days.